Hi, hello, welcome to this next lesson. This will be the third lesson of Unit 3, Introduction to Inequalities. Hopefully you've worked with some inequalities before. We're going to keep working on them and go a little bit deeper into them. Let's get started. During this lesson, you're going to learn how to create equations and inequalities in one variable and use them to solve problems. Alright, so here's just some symbols, what they generally mean. My first symbol here is greater than, more than, larger than, above than, so we would state that as 9 is greater than 5. My second symbol here is greater than or equal to. At least is not less than, minimum. So we have things like 5x is greater than or equal than 5. My third symbol here is less than, smaller than, or below. 4 is less than 8. My fourth one here is less than or equal to. At most is not, more than, maximum x is less than 4 would be my example. My fifth one, hopefully everyone's comfortable with that, is equal, same, is. And then lastly, if I have an equal sign with a line crossed through it, means not equal or different. 2 is not equal to 1. Alright, so when we're solving algebraic equations, we want to understand the properties of inequalities, which is critical in solving algebraic solutions, or to solving algebraic equations. So we can use inequalities and equations to represent graphs and solve different situations. Alright, so let's just solve some inequalities real quick. As I'm going through and solving for these, I'm going to treat my inequality exactly like an equal sign. The only time I'm not is if I have to multiply or divide by a negative, then my inequality will flip signs, will flip directions. I don't know what that's supposed to be. Okay, so that's the only time something is different. Okay, so 3x divided by 9. I'm going to divide 3 by both sides, which gives me x is less than 3. Okay. On my second one here, I need to get x by itself, so I'm going to divide by a negative 2 on both sides. When I do that, my inequality changes direction. It flips around because of this negative. Okay. My next one's a little bit more involved. I'm going to have to do a couple of steps. I'm first going to subtract 4 from both sides. I get 2x less than or equal to 12. Then I'm going to divide both by 2, and we get x is less than or equal to 6. Box these up so we know what's what. Okay, on my equation on the far right, I'm going to first multiply both sides by a negative 3. Those cancel out. I get 3x plus 5. Since I multiplied by a negative, my inequality is going to flip around. So I now get less than 9. Then we're going to subtract 5 from both sides. And I get 3x is less than 4. Then I have to divide by 3. And we get x is less than 4/3. Notice through all of these, all I'm doing is doing the opposite of what is already happening or already occurring for that inequality. Okay. And a lot of what you're going to do is doing word problems. And this is when things become more real life situations. And a lot of the time you're doing this math without thinking about it, but this is what you're doing. So Jeremy is selling ice cream sandwiches to raise money for his marching band. Each ice cream sandwich is $2.50. Jeremy needs to raise at least there's a keyword there, at least $120 to fulfill his portion of the fundraiser. How many ice cream sandwiches does Jeremy need to sell? All right, so there's my question. How many ice cream sandwiches does he sell? We know he needs at least $120, and we know that each ice cream sandwich is $2.50. So what we're going to do is we're going to first say X equals the number of sandwiches sold. Okay, we know he has to sell at least $120, okay? So we're going to worry about the inequality after we write this equation. We know that each sandwich is $2.50 per the number of sandwiches. So I'd say 250 times X. Now we get to that at least. So we have to think, is 120 the smallest amount that I need, or is it the biggest amount? It's the smallest. I need to get at least 20. So this 250x can be bigger than 120. 120 is the smallest. So I want my alligator to be the biggest possible thing. So I'd say 120 is less than or equal to 250x. Let's try another one. Okay. All right, so I'm going to underline some key stuff as we go along. So Juliet is playing a game online and is mining precious jewels. And she comes across a large group of diamonds. The most diamonds she has ever mined is 5. The most diamonds she's ever mined is 5. Write an inequality expressing how many blocks she needs to mine to beat her record. All right. So once again, I'm going to say X equals number of diamonds mined. So we have 5. We have X. She wants to beat her record, right? So that means X has to be bigger than 5. So I'd say 5 is less than X, or you could write it as X is greater than 5. Either way works. All right. Okay, James and Christian are getting supplies to make s'mores. It's going to cost $3 for the graham crackers and marshmallows, and at least 50 cents for each type of chocolate bar, because we like to have different types of chocolate. Write an inequality describing how much they will spend on s'more supplies. Okay, so this is what we know. We know it costs $3. Oh, first, you know what? Let's identify what my variable is going to be. So we know X is going to be the number of different types of chocolate. Okay, so this is what we know. We know it's going to cost $3 for graham crackers and marshmallows. That is a set number. Okay, then what I know is that it's going to be 50 cents for each type of chocolate bar. So I get 0.50. I don't know how many different types. So there's X. And then we just have to say our cost. So we're just going to say cost based on X, right? What do we know? Let's see. Here's my keyword here. At least 50 cents. So 50 cents is the smallest amount that the chocolate bars could cost. They could cost more. So, since I know it's at least, I know it could be bigger than that. So that's the smallest it's going to cost. Is if every candy bar we got cost this 50 cents, that would be my smallest amount. But it could cost more. So that's why the inequality is faced the way it is. All right, one more. The velocity v of meters per second of a ball thrown directly up in the air is given by v equals 20 minus 10t, where t is the time in seconds. At what time will the velocity be between 13 meters per second and 22 meters per second? My guess that's supposed to be t squared. So that's what we're going to do, t squared. Alright, where t is the time in seconds, at what time will the velocity be between 13 meters per second and 20 meters per second? Alright, so this one's a little bit different because we're going to be in between something, right? Let's see. Well, it kind of tells us everything, right? So we know that it's going to be between 13 and 22, and my equation for it is 20 minus 10t squared. What times will the velocity be between 13 meters per second and 22 meters? So we know it has to be between those, so my velocity needs to be bigger there, smaller there. No, you know what? I don't need that squared. Okay. So it actually wants us to solve for t here, which isn't a big deal. Anytime where I have it's like I have two different equations here. So what I'm going to do is do exactly what I'm going to do, but instead of doing it to two sides, I'm going to do things to all three sides. So if I subtract something from my middle equation, I have to also subtract it from my two ends. Let me show you what I'm talking about. So my goal here is I want to get this t by itself. So what I'm going to do is I'm going to subtract 20 from there, but I also have to subtract 20 from there and subtract 20 from there. Okay, so what I get is I get negative 7 is less than negative 10t, which is less than 2. Okay. Next, I need to divide by negative 10. But notice I'm dividing by a negative, so I get positive 7/10. My inequality is going to change, is greater than t, which is greater than negative 2/10. So we're going to rewrite this. We're going to say, and I'm going to simplify, negative 2/10 simplifies to negative 1/5 is less than t, which is less than 7/10. So let's think about what this is meaning. Is we're talking about meters per second. So right here, I'm not going to have a negative time, right? So that means this ball is being thrown up, which kind of makes sense, right? Because I'm standing up, so I'm not going to be able, so that height is kind of irrelevant here because of this negative happening. 7/10 is just really quick here. I guess this isn't a quadratic. This is a straight line. We're assuming there's no gravity and it just keeps going up. We're on the moon or something. And at 7/10 seconds, it hits that height. Well, it hits that velocity, I guess, between 13 meters per second and 22. So anywhere in between those is where it's that velocity, and then I guess it would be increasing. All right, if you have any questions about this, please come and talk to me. I'd be happy to help you. Thanks. Bye.